Today, guys, we're going to learn about place value sections, also known as place value boxes. So let's title a new page in our notebook, Place Value Sections. Basically, what we do with place value sections is we can take these big multiplication problems and we can break them into parts using the distributive property. So let's write down distributive property just to remind ourselves what that means. So in the distributive property, if you have a problem like 4 times parenthesis 3 plus 6 parenthesis, distributive property says I can take what's outside of these parentheses and I can apply it to each number. It's like passing out papers. I'm going to give the 3 a 4 and then I'm going to give the 6 a 4. Okay, so what this ends up looking like is 4 times 3. Bring that plus sign over, plus 4 times 6. And then you can solve the problem and you'll get the same solution as if you did 6 plus 3 times 4 by doing 4 times 3 plus 4 times 6. Okay, so we're going to write down a pretty big sentence, but I think it will be good for you to have this and be able to refer back to it. Okay, so the sentence says the product of a number so the product means multiplying. The product of a number and a sum, which means adding. So let's put times up there and addition up here. The product of a number and a sum is equal to the sum of the products of the number and each of the add-ins. So that's just talking about the distributive property. It's saying the product of a number and a sum, so this would be adding these two together and then multiplying it, is equal to taking each addend, the 3 and the 6, and multiplying both of those by the product out front. Okay, so now we're going to draw some place value sections, and this is actually kind of fun. So usually you start with a rectangle, and you'll see this done with equal size boxes, but I'm gonna do it with smaller boxes just to kind of show the distribution. Okay, the number we're going to work with on this place value section is 43 times 67. Okay, so what you do with place value sections is you take the first number and you put it along the side, but you break it into its parts. So 43 is 40 plus 3. And the reason I put the 3 so low down is because if you were to talk about how much of this square is worth 40 and how much is worth 3, the 3 would be worth very little. Okay, down here I'm going to draw a line straight across. This one would be worth 3, this one much would be worth 40. Now we're going to look at the 67. 67 is 60, we're going to write this one along the top, plus 7. And then we're going to break that out as well. The next part is to go ahead and do the math in each section. So in this section, it's 60 times 40, or 40 times 60. because that's associative property. That equals 2,400. 6 times 4 is 24 plus the 2 zeros. Let's go down and do this section now. This section would be 3 times 60. 6 times 3 is 18, and an extra 0 is 180. Now we'll do this section, which this is a 40 times 7. 4 times 7 is 28, plus that 0 makes it 280. And finally this section, which is 7 and 3. So let's go 3 times 7, which equals 21. Okay, now we take all of our totals and we're going to add them together. So we have 2,400, and I'm going to go from largest to smallest. Okay, then we have 280. Then we have 180, and we have 21. If we add all of those together, we end up with 2,881. So I didn't have to use a calculator. I didn't have to create a huge, long problem. It's pretty simple when you use the distributive property to break them into parts and then go back and put all of those parts together. Okay, let's do one more. This one is going to be 39 times 54. Okay, let's draw a rectangle first. I'm going to go with 30 and 9 is 30 plus 9. Draw my line. I know I'm going to write in those boxes though too, so I don't want to make them too small. 50 and 4 is 50 plus 4. And let's do the sections. I have 30 times 50. 5 times 3 is 15 and 2 zeros. I have 30 times 4. 4 times 3 is 12 and 1 0. I have 50 and 9. 9 times 5 is 45 and 1 0. And then I have 4 and 9. 36. Okay, list them from greatest to least. 1,500, 120. Oh, sorry, 400. It doesn't matter if you do greatest to least, especially since we're just adding. $2,106. It's kind of cool. It's an easier way to break down those problems. You're gonna do some IXL, and I believe they call it place value boxes, and that's fine too. It's because it's all boxing things up. And then you're going to do 4-3 on Google Classroom and turn it into me. Good luck.